Okay, so for example number 10 class, we are also to determine the magnitude and direction of the resultant force here. But take note that we are given here 3 forces, okay? But of course, the process are just the same. Okay, so we are to find the magnitude of F sub r and the direction, which is in theta. Okay, so in order for us to solve that class, so for our F sub r, okay, so we simply, like you've said, use the square root of the sum of the square of the components there. And in order to solve for the Frx, okay, we have to summate the forces along x, which includes 3 forces. So x component of F sub 1, x component of F sub 2, and x component of F sub 3. While for the Fry, so summation of F sub y, so F1y rather, F2y, and F3y. Okay, so we will just simply get each of the components of our given force. Okay, so to do that, so let us first examine our F sub 1 here. So if you notice, F sub 1 is directly on our x-axis. Okay, so since it is to the left, so obviously what is the x component of your F sub 1? So since there's no angle in class, if you could notice, cosine of an angle of 0 is 1, as you can see there. So that means that the value of the x component here is still 400, but since it is to the left, so it will be negative 400 Newton. Class, how about for the y component? So the y component of your F sub 1 is 0. Why is it 0? It's because there's no y component here, and that's because it is exactly on the x-axis. Okay, that's why the y component is 0. Now how about for F sub 2? For F sub 2 class, we have here given the angle, but it is with respect to the y-axis. Okay, it's with respect with the y-axis. So obviously this is the F sub 2, which is 250 Newton. So this is the angle that is given, which is 45 degrees. So obviously this is our y component, and this one is our x component. Okay, so using to solve for the f2x, okay, I'll just use, or we will be using the opposite side, which is the sine of the 45, and the opposite here is f2x, and the adjacent and the hypotenuse is f sub 2. So therefore f2x is f2 sine 45 degrees, or that is f2 is 250 times sine 45 there. So f2x is 250 sine 45, that is 176,777, and the unit is Newton. Now how about for the y component? For the y component class, okay, so it will be adjacent to this angle here. So using the cosine 45, so adjacent is f2y and hypotenuse is f sub 2. So f sub 2y is f sub 2 cosine 45 degrees. So 250 Newton times cosine 45 degrees. So your F2y is equivalent to, take note guys, it is still 45, so expect that it will be equal. There, it's still 176,777 Newton. Okay, now how about for the F sub 3? Now notice class that our F sub 3 is in the form of slope. Instead of angle, we are given here a slope 3, 4, and we have a hypotenuse of 5. So in this case, instead of using the trigonometric identities cosine and sine, so we will be using the similar triangle, the ratio and the proportion, okay, in order to analyze this. So redrawing our F sub 3, this is F sub 3. F sub 3 is equal to 200 Newton, okay, and we are given here slope, which is 3, 4, and the hypotenuse is 5, okay. So obviously class, in this case, your F sub x is this one, or your x component, and your y component is this one, okay. So using your similar triangle, okay, can you see it clearly? This is F3x and F3. Okay, so using your similar triangle, so since our target is this F3x, okay, so let us write this F3x. So what is the similar side on the small triangle? So that is 4. Okay, now since we are given the hypotenuse, which is F sub 3, so the corresponding side here in the smaller triangle is 5. Can you follow? So therefore, F3x will be F3 times 4/5, or that is, your F3 is 200 Newton times 4/5. Okay? And your F3x will be 200 times 4/5. So 200 times 4/5. There. And you'll have 160 Newton. While for the y component, okay, so this is the y component part. So let us put F3y. The corresponding side is 3. There. And using the given, which is 200, which is F3, and the corresponding is 5. Can you follow? So F3y is 3/5 of your F sub 3 there. So substituting, we have 200 Newton. So F3y is 3/5 times 200, 120. So we have 120 Newton. Okay class, so these are the components of each of the 3 forces. Okay, so I have made again a copy of the values of the components. So for now, we will be solving for the resultant force at the x component. But before that, again, we have to make sure that the signs are carried. Okay, so for the F1x, so obviously it is to the left, so we have there the negative. For the F2, so since the direction of the arrow or the force is to the right and upward, so both of them is positive. While for the x component here, since the F sub 3 is to the left and upward, so the x component will be negative here, but the y component is positive because it is upward. Okay, so for our Frx, so we will simply add each of the x component here. Okay, so substituting, we have negative 400 Newton. F sub 2 is 176. And your F sub 3 is negative 160 Newton. So therefore, we have negative 400 plus 176.77 minus 160. There. Okay. So we have negative 383,223. Okay. Negative 383,223. Okay. Now, how about for the FRY? For the FRY, we have F1Y, F2Y, F3Y. So we have 0. We have 17677 Newton plus 120 Newton. So we have FRY is, we have 177 plus 120. We have 296.77 Newton. Now take note, class, that your x component is negative, your y component is positive. So what do you think? What quadrant does our force or resultant force belong? Is it first quadrant, second quadrant, third quadrant, or fourth quadrant? So negative x and positive y. So obviously that is second quadrant. So therefore, this is our Frx. Okay, and this is our Fry. Can you follow, class? Because negative here indicates to the left. Okay, to the left because x component, and positive so upward. So obviously or rather just like this, this is our Fry. Fry. Okay, so our resultant force will be here. Okay, so using the Pythagorean theorem here, so F sub r is square root of the sum of the squares. So we have negative 383,223 Newton squared plus your 296,777 Newton squared. Okay, so you have to get the square root of that, and that will be the magnitude of your F sub r. Okay, so we have here square root of negative 383,223 squared plus 296,777 squared. I am sorry, square root of, so we have 383.223. By the way, class, I don't put the negative sign because mas square naman siya. So the same lang naman. Okay, 296.777 squared. Okay, so we have 484,702 Newton. And this is already, class, the answer for our magnitude. Okay, now how about for the theta or the angle? So in this case, class, our theta is here, or with respect to the x-axis. So using this, okay, I'm sorry for that. So I'll just erase this one. Okay, so for the theta, so we have what trigonometric identity? So the same, class, we will be using the tangent, using the y component and the x component. So tangent theta, so Fry, Frx. Okay, so theta here is arctan. So using the Fry, which is negative 383,223 over your Frx is 296,777 Newton. There. So theta is, okay, so we have arctan, we have negative. Don't forget to carry the negative, class, so that it will give you the exact angle. Okay, there. So we have negative 52.245. Class, take note, negative 52.245 degrees. Okay, negative. Now, if you look at our location, okay, it should be in the second quadrant, right? So usually our reference is when we measure is from here going there. So starting here, this is your 0 degrees. So going here, this is 90. So this one is 180, right? So since our location is at the second quadrant this way, okay, so from the reference, how much is the angle, right? That's how we measure that. But as you can see, okay, the angle is negative 52, which is what? Which is located right here, this one. Because if you measure clockwise, kasi this is counterclockwise, class, this is counterclockwise. Okay, the direction is counterclockwise like that. But if you measure clockwise, which is from here going here, it will become negative. Okay, so which means that the location of your angle is right here at the quadrant 4. So how are we going to express that? That it should be here in the second quadrant is because the location of our force is at the second quadrant. But your angle says it is in the quadrant 4, which is wrong. Class, it is wrong. Okay, if you answer this, that is wrong. It's because, like you said, the location of negative 52 is right here in the quadrant 4. But your actual force is located at the second quadrant. So to correct that angle, class, all you have to do is you have to add 180 degrees. Okay? Because if you can see here, if you add 180, if you just do it like that, okay, so it will, if you add 180 here, so it will move there. Okay? So if you do that, you'll have negative 52.245 plus 180, you'll have 127, positive 127.755. Can you follow? 127.755, or that angle, class, is right here. This angle 127.755, is that correct? Is that correct? Now let us check, let us check, class. Can I erase this part? Because we don't need that anymore. Let us check if this 127 is correct. Okay, let us check. So from here, measuring there, that is 90. Okay, 90, 0 to 90, supposedly the angle. Here to here, that is 90 to 180. Okay, so therefore this 127.755 is where? So you measure 0 going here. Can you follow? So that is like this. So this from here, this is our angle, which is equal to 127.755. So is that correct, class? Is that correct? Because based on our position, it should be here. This one, our angle should be here, respect here. So how are we going to do that? So you can just simply have it like this. Since this is 127, right? So the total angle here is 180 degrees, right? So you can simply subtract it. So 180 minus 127.755 degrees. So you'll have it 180 minus 127.755. You'll have 52.245 degrees. Okay, 52.245 degrees, which means this is the angle in this part only. Can you follow, class? In this part only. Okay, but if you measure it from your reference point, which is 0 degrees here, going here, that is 127.555. Now, this should be the final answer. Positive 52.245. Now, going back to our solution earlier, the answer is negative. Okay, so what can we conclude from here, class? Therefore, class, we conclude that if you want to solve the actual angle in that position, so therefore we have to substitute here absolute value of your components. Take note, we have to use the absolute value. So if, for example, your FRY is negative, so you have to use positive here. So do not carry the negative, or do not carry the direction. Can you follow? In order to give you the exact value of theta at that location. But if you are trying to determine based on the reference, so you'll have to do this. You have to check it, class, in the positions of the quadrant. Okay, so again, the answer here is positive 52.245 and the magnitude is 484,702. And that's the solution for example number 10.